Off we go. All right, it's 2 hours UTC, and it's time once again for Astronomy Daily Live. Hey, everybody, welcome, welcome. Come on in, come on here, gather on in for another hour-ish or so long conversation about astronomical things, astronomical topics, space, all that kind of stuff, science, um, and various tangents that may or may not show themselves. So yeah, so definitely want to say hi to Jim, Carolina Sky Astronomy, over in the chat, and chatting with him sort of pre-show here a little bit, and making sure that Nightbot is operating up to at least expectations. so did a little bit of a test there. I see that Tom's in the chat as well. So very cool. Great. Glad to have everybody here. It's raining again here. Raining once again. So yeah, I don't know what's going on with that. But yeah, I guess it's supposed to rain through tonight and into tomorrow. So don't know. I'm still crossing my fingers for what will be for me Saturday morning, March 16th. There's a series of events happening at Jupiter from our point of view that I'm gonna try to record, and for various purposes. One being just to see it, right, or just to see these two events. Both Europa and Io are going to be passing into the shadow of Jupiter as they pass behind it from the sun. And this time of year, we're Jupiter is about as far away from the sun as it's going to get from sort of our point of view. So we're sort of looking at Jupiter on sort of its right-hand side, right? We're sort of, not dead on, sort of over that away a little bit, right? And so since we're looking from the side, then we can therefore see part of Jupiter's shadow as it is cast behind it, right? The sun's in front, Jupiter's here, and then its shadow gets cast all the way behind it. And if we're sort of looking from the side, then we can actually see the moons move into the shadow. And in the case of Europa and Ganymede and Callisto, they're actually far enough away from the planet as well that you can see them pass into the shadow and then pass out of the shadow. So it's very, very cool. Stephen Warner, hey, nice to see you here. Welcome, welcome. So this is Astronomy Daily Live. We talk about astronomical things pretty much each and every day around 2 hours UTC. This is for pros. This is for the amateurs. This is for the newbies. Everyone is welcome here. We can go multiple levels here, and I like to keep the conversation a little elevated, right? So and my reasoning for doing that is because if information is always coming at you at a level that sort of you can handle and understand and everything, you're adding to your knowledge base a little bit, right? But if the information that you get is sort of above your head, right? Right? Flying over your head, well, you know, you can sort of reach up and grab pretty far over your head, right? So what I like to do is I like to keep it at a level where, for the most part, right, on average, this kind of stuff is flying over my head a little bit, right? And but it's not out of reach, right? It's not out of reach. Um, Now, what flies over my head is going to hit somebody else, just right there, right? It's like, oh man, and what flies over my head might be completely out of reach to you, right? But that's okay. That's all right. You know, we're all we're all sort of like children here, right? 3-year-olds who can't read, who can't write, but can see things really well and sort of experience things really well. So you know, I like to look at a lot of pictures here because that sort of allows us occasionally to understand things a little bit more, rather than trying to read all the words and look at all the math and all that. A lot of that to me is completely out of reach too. Anyway, so welcome. Glad you're here. I'm gonna check the chat one more time. Cool. Uh, yes, astronomy is the dope. Is definitely the dope. Hey there. All right. Well, I'm going to get to the panel, who seems to be tapping me on the shoulder here. So hey there, Mr. Earth Radio. What's going on, Ron?
Hello. Doing good.
Good. Now, Ron, let me ask you this: are you a Ron or a Ronald?
Ronald officially, but I'll accept anything as long as I'm not called late for dinner.
All right. Sounds good.
So if you're having dinner and you call me, I better not be late. I'll be really upset.
Absolutely. Yeah. I'm exactly the same way. You can call me whatever you want.
Yeah.
Just don't call me late.
That's right.
Yes. Absolutely. Well, cool. Excellent. Glad you're here. And once again, from the deep south is Bobby. Hey, what's going on?
No, Bobby.
Hello. What's up, Ron?
Hey, Bobby. Bobby Robert. Hey, is Bobby Robert or is Bobby?
It's B-O-B-B-Y.
It's Bobby. Yeah. Okay.
Very cool. Very cool.
And Matt is Matthew, right?
Yes.
Officially.
Officially.
Yeah.
But
we'll call you Matt. There's too many letters in your name, so we just call you Matt.
Yeah.
Way too many. Way too many.
Just like we were talking about earlier when you said we can read all the words, but that would get kind of boring.
Yeah, absolutely. It's just me, and it's just you. Yeah. Anyway, well, great. I am really. Yeah, I'm really glad everybody's here.
James Dugan in the chat.
James Dugan, hey.
James. How you doing, James?
Nice to see you too. I think James is down in Australia, if I remember right.
He is.
So yeah, very cool. Very cool. Always.
Today was officially one of the
right
first.
Right now, I'm monitoring the activity for my IPTV service. The servers, for some reason, they got shut down, and they're doing some maintenance at that point in time.
Oh. All right.
Today was officially one of the first days I had a no glove. I call it a no glove day. So.
A no glove day.
Warm enough for no gloves.
Wow. Yeah, that's
exciting.
I can't imagine anything more exciting than that. I
Well,
just, I that
when you
that's
go
just
from -30 to 0, and 0 seems to be warm, you know,
yeah, yeah,
you still need gloves though. But now
right.
when you get above 15 degrees or so, 20 degrees, you don't need gloves too much, and then it becomes tolerable where you don't have to have a glove on every time you go outside.
Oh man.
There are conditions when you don't want to go outside without the proper skin coverage, or you'd be in trouble.
Oh, absolutely. Yeah, yeah. That's and that is something that I
I
definitely don't have to
never
contend with here.
knew that Oz is one of the cities in Australia.
Uh, yes, I think that's right. I think that's right. Yeah, just point me to Oz. That's a great place. Great, great, great place. Yeah, mow the grass. Yeah, yeah. It's well, there, you know, the the concept of an average anything, right, is a statistical sleight of hand, right? There it is extremely rare to have what we would call an average anything, right? Average winter, average spring. It never happens, right? You you know, like I said, it'd be extremely rare to ever experience an average day, right? Those kinds of things just don't happen. So I think our ideas about crazy weather and stuff, I don't really know what the basis of that is, right? Because it's like, well, how do you determine if this is, uh, 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 you know, I mean, what are you using for your basis, right? And it's this average thing, right, which doesn't exist. So you're trying to compare something, to things that don't exist. I don't know. It's just a little weird.
Well, of
Uh,
course, you would have an average after a period of time. Say if you have 10-year period, you would definitely have an average of what you could work on.
true, but
Yeah.
you'll never experience an average, ever. It just doesn't happen, right?
Because you won't,
Or
because you won't have the extreme, is what you're saying. Uh,
well, we always wiggle around the average, but we never actually experience the average,
mm.
ever, at all. So anyway, yeah, it's
All I know about average is that I know it's cold here in the wintertime.
yes.
I know that for a fact.
Well, that is much more important, I would say, and yeah, you're exactly right. But you know, um, there are lots of people who really really like that, and or don't mind it, so they stay. Either because they choose to stay or they're stuck, right? Could be either way.
I'm just crazy. That's all.
Well, there's another explanation. And you're in the right place.
All right, all right. Well, it
Hey,
does offer.
Dugan, Ron, are you still snowed in?
Uh, no, it's pretty nice now. I was actually pretty surprised on Sunday morning when they came and cleaned my driveway. I wasn't expecting that. I didn't call them, and I was gonna call them on Monday, and the guy came on Sunday morning to clean it out, which was pretty nice. We didn't have church on Sunday though because the roads are too bad to go anywhere. When it snows here and it snows bad enough to where they shut the roads down, you don't really get to go driving around like you do in other places. So I don't know if anybody really has any road conditions where they shut the highways down.
Oh yeah.
Maybe if you have a flooding season, you might have that trouble. If you have rain season, but other than that, you wouldn't have too much of a problem with that. But we have the issue where if it snows, and it gets to where the other day when I was on the road going to get my medication a couple of weeks ago, and I couldn't tell what the sky was. I couldn't tell what the field was. I couldn't tell what the road was because it looked like the field. And it was just a good thing I knew I had to keep going straight, so, so it's not too hard, it's a straight road. But it's a little bit dicey when you get out there and you cannot see the road. And you just kind of got to know where it's at and hope that you don't wind up in a ditch. But it
Yeah,
was
I always
one of those
always
medications I had to get though. So
yeah. Well, you do what you got to do, but I don't worry so much necessarily about me. What I worry about in those kinds of conditions, or like with fog, right? Um, is what's that other person, you know, are they going to do something really, really stupid, like try to pass somebody else,
yeah,
right? And it's like, oh man, so yeah, well, I mean, obviously, you had to go for it, so you did, but
From
oh man,
across the pond, here is Indy Cowie.
hey there, Andy, nice to see you. Yeah,
The pond, that is.
yeah, Ice Road Trucker Ron, yeah.
yeah.
That's great.
But yeah, if they say that not safe to get out, I usually don't go anywhere. I just stay home, and that can get kind of nerve wracking though when you got to stay home. I'm glad I have internet, and thankfully we haven't lost any power recently. So as long as I have the internet, I'm good. So
Yeah,
um,
absolutely.
man,
Absolutely.
back in the day, there was not internet before, and of course you didn't have cell phones or anything like that. So you were pretty much when you were snowed in, you were snowed in. There was no
Snowed
getting
in.
around. At least here you can travel to a warmer place in your head anyway.
Yeah. Well, and if you've got a radio, you can listen to that. If you've got
Oh
a
yeah,
ham radio, you
oh
know,
yeah,
you can actually
CB
communicate.
radio.
Yeah, CB or whatever. Um, uh, so yeah. There there's always been means to communicate on a wide scale, and the internet is just sort of the latest one of those, and
yeah,
I got to say, I mean, it's doing pretty well as long as it works, right?
right,
When it works, oh my gosh, it's like wow, right?
yeah,
And when it doesn't work, I feel like I've been thrown back to the Stone
right.
Age, right?
Uh, with my internet speed, I don't have the best, but it's better than none. You know, and
Yeah.
in my situation, though, if the ice gets too heavy on the lines, it could, of course, snap, and
Wow.
that can be anywhere, I guess. And yours might be birds landing on the lines or something. Yeah.
Yeah, our most of the time, at least more than half the time, when we have a power outage here, it's because somebody has hit a pole.
Oh, okay.
Okay.
Usually, someone drunk, probably.
Okay.
That's usually how
So,
that goes.
Tom
Yes.
Ben Scholar, on this day in 1811, Urbain Le Verrier was born. Astronomer and mathematician who specialized in celestial mechanics. He is best known. He is best known for predicting the existence and position of Neptune using ordered mechanics.
Oh, cool.
Le Verrier sent the coordinates to John Gottfried Gale in Berlin, asking him to verify.
Yep.
Gale found Neptune the same night he received Verrier's letter.
You know how unbelievably impossible that actually taking place. You know how incredibly impossible that is. That
Yeah.
that was not that was not skill. That was luck.
Yeah.
That was pure absolute luck,
Well, now
right?
some of it had to be knowledge or skill because you had to know when to look. Okay. So in a way, I mean, I see what you're saying. It would be luck. You're right. But at the same time, if you have a base to start from, and you say, okay, I'm going to look at this time, and just keep looking at this time every night until something happens, and hopefully within that time frame, something will happen. And I'm sure that he's done all the mathematical calculations to figure it out. You
Well,
know.
yeah, and it's an interesting story, which I don't know all of the details, right? But the idea was is that they were making very very careful observations of the motions of the known planets,
Right.
and noticed that there was something
Tugging at it.
not quite right. Running over time, their models predicted that the planets should be in a particular place,
Mhm.
and when we go and observe at that time, they're in a slightly different place, right? So it's like, okay, what's going on there? Well, Newton taught us, right or wrong, that to change the motion of something requires a force of some sort to do it, right? So from that, you can build a model, right, that looks at the differences in the orbits of the planets, and take that as sort of your input data, right? Feed that into a model and get a prediction as to where uh, you know something else out there would be, and then using that information, predict where it's going to be in the sky. And so that's what this guy did, right? Back, what, probably like 150 years ago or so, right? Um, predicted that location at that particular time close enough such that this other guy uh, found it um, on the same night, at least, that he got the information. So it wasn't a hole in one. It probably wasn't a bullseye, right? But well, I mean, it was more of a bullseye than a hole in one, I would say.
Mhm.
Um, uh, yeah, because that same night he actually saw it. So it was nearby, right?
Mhm.
So that's pretty amazing. And yeah, I mean, I still say that is quite a bit of luck. That was a very very well educated guess,
Oh
but
yeah.
wow, pretty amazing.
But it's
So
just like
cool.
when they do the mathematics on even a solar eclipse or whatever in years advance, you know,
Mm-hmm.
and they got it to the very day. I mean, that you can go with history, of course, and take a look at what the sun has done. And over time, you can take a look, you know, and say, okay, well, it did this time, and it does this every so many years or whatever, and you can figure it out that way. But I don't know, discovering something new for the first time you're seeing, that would be kind of challenging, I would think.
Yeah, yeah, and in this case, I mean, he saw something where there wasn't supposed to be anything, right? So pretty amazing. Yeah, yeah, that'd be an interesting story to actually get into a little bit, because you don't hear a lot about those kinds of things. You know, the discovery of Neptune. Um, but so very, very cool though. So he's the guy that did the calculations, and ran the model, right? Um, he's the guy that had the model that then sent the coordinates to this other fellow, and you found it. Wow, yeah, that's just absolutely amazing. Pretty cool. All right, excellent. Well, thanks, Tom, for that tidbit there. That's always
I'll be right
always.
back.
All right, very cool. You may. So I was over on archive.org and found kind of an interesting paper. I'm gonna come over here and I'm going to mute Mr. Ron like that. There we go. Okay. So yeah, I was over on Archive, which had already posted the latest astronomical papers for March 12th. And so this was just one of them that caught my eye. Let me check the chat. Starseed, hey there, Starseed. Nice to see you. Welcome. I think you might be a newcomer in here, so howdy. This is
welcome,
all.
Starseed.
Yeah, welcome, Starseed. So this is all about astronomical talk and space and science and that kind of stuff. We just sort of nerd out each and every day at 2 hours UTC. And yeah, I just, as I was just saying, I was over on the archive.org website and noticed that this new paper here had just come out. So I just I was looking at it before the live stream started, so I thought, well, you know what? Let's just take a look at this together here. So I'm going to share my screen, and we'll come over here. So this is the upcoming mutual event season for the Patroclus. I don't know how to pronounce these. I'm just going to call it PM. So it's a Trojan binary, right? So the Trojans are a group of asteroids. Let's see here. You know, it's so much better to just show pictures. Trojan asteroids. So Trojan asteroids. Is this what I'm looking for? I think this is what I'm looking for. So what we've got here is a map of the solar system out to the orbit of Jupiter, right? So here's the Sun, here's Mercury, Venus, Earth, Mars. Asteroid, the main asteroid belt, right? And Jupiter's orbit way out here, right? So as you can see, at what would be the Sun, Jupiter, L4 and L5 points, which are sort of a gravitational null. There are these groups of asteroids that have sort of congregated in these areas. I believe this is L4, this is L5. because the Trojan asteroids exist at at Jupiter Sun L5. I believe that's L5. You can see that there are other uh, families of asteroids too that are sort of being affected by Jupiter, right? You know, the Trojans wouldn't be here, or the Greeks wouldn't be here if Jupiter wasn't there, right? And this is a very specific angle. I forget exactly how that all works out. But, you know, it has to do with the mutual mass of Jupiter and the Sun and, you know, all those points. And like I said, it's
But the other are the Sargasso seas of the solar system.
the Witchams. Yeah. Yeah. Okay. I've never actually heard it put that way. That's kind of interesting, right? So the
What is this?
what's that?
I see that. Okay, now I see what I'm looking at.
You got it?
Yep, I had to look in here.
So anyway, here are the Trojans, right?
Okay.
And you know, I thought that the Trojans led Jupiter. So let's see if we can work this out. Whoop, we can work this out here. Trojan asteroids are simply Trojans, or large group of asteroids that share the planet's Jupiter orbit around the Sun. Relative to Jupiter, each Trojan librates around one of Jupiter's two stable Lagrange points. Okay, so L4 and L5, and 60 degrees ahead and 60 degrees behind. So that's sort of the magic angle here, is 60 degrees, which you know is of course pretty interesting, right? Because that's that would tend to sort of make this an equilateral triangle, right? With Jupiter, Sun, Trojans or Greeks make a very equilateral triangle. Yeah. If this angle here is 60 degrees, right? Because the sum of a triangle is 180 degrees. So, all right, well, cool. So, all right. Yeah, and I think all the green ones are technically Trojans, right? But then I don't know exactly what the history is here, but these ones leading Jupiter, right? So we're looking at this system from the top, right? So everything is going around counterclockwise. So the Greeks lead, and then Jupiter comes up behind, and then the Trojans are behind. Now, I mean, yeah, I thought that the Trojans would be in front, but what do I know?
So now, can you see those with the telescope?
Well, these, you know, that is actually one of the questions that I had was you know, how bright do these Trojans actually get, right? And so here, you know, I don't know if binary systems with Trojans is common or not. I'm not exactly sure. I have heard that a lot of asteroids seem to be in some kind of binary or multiple asteroid system. But this one, I guess, is sort of confirmed that it is. Yeah, and in fact, they're calling it the first known binary Jupiter Trojan. So, so yeah, I guess the Trojans, they either haven't found any other one, or the ones they're looking at they can't tell, or there just aren't any, or you know, it's rare, and you know, if it's rare, it's like, well, why is it so rare? Yeah, I have no idea. Anyway, so yeah, what I was interested in is, I guess these asteroids, because of their orbits, right? Every 6 months, sort of align themselves in such a way that we can observe one asteroid passing in front of another, right? So doing an occultation, and uh, the light curves for those kinds of things might, well, would be really, really interesting, um, uh, because you'd be able to discern perhaps a shape. Um, you get better data on the orbits, um, which means you get better data on the masses of the two systems, all that stuff. So yeah, I was just kind of interested in seeing how bright this system is, and so I was going through the paper here, and I guess it's been observed with Hubble and with Keck, right? So Hubble, of course, is a space telescope. So it's like a 1.5 meter telescope, but it's out in space, so it has very, very good resolution. It can see at a lot of wavelengths that we can't, etc. Right? In this
I'd like
case,
to
they.
welcome Amethyst Crystal Photography in the chat, another newcomer. Tom Van Scotter, this is where the rules about being a planet gets very confusing. I thought one of the rules was the object must have cleared the neighborhood of its orbit.
I think that is one of the rules. Yeah, I think that's rule number 3. And in fact,
What now?
Oh, go ahead, Ron.
What was the statement? Rule number 3? I missed it.
Oh, the.
Okay, and James Duger said that the Shoemaker asteroid came from the Jupiter Sun L5 area or from the Kuiper belt.
Oh, okay. Let's see. Yeah, let me get to the rules first. The International Astronomical Union several years ago defined what a planet is, and that's when Pluto got pushed off of the list, right? And everybody's upset about that. I'm not. I think that Pluto is awesome, and I don't really care what it's called because it's absolutely fantastic. Yeah, I don't quite understand why everybody is so upset about that. And if the definition of planet has to change, then the IAU is probably the place to make those kinds of changes. And as we go out and detect and look more closely at these exoplanets, our definition of a planet is probably going to continue to change, right?
Amethyst Crystal Photography, you are subbed and bailed to me.
Very cool.
Or should I say, I have subbed you and bailed you, Amethyst Crystal Photography.
Excellent, excellent. Yeah,
and,
I will.
And Carolina was mentioning to the Amethyst Crystal Photography. She gets some great shots of the sky.
Cool. I will have to check that out. I'm always looking for new things for sure. But James Dugan, the Shoemaker asteroid that I think you're talking about was actually Shoemaker-Levy 9, the comet that broke up into at least, I think, like 21 pieces. And it was broken up by Jupiter. Now, probably. Now, we didn't
I'd like to
actually...
welcome Astro Live Channel and Tim Robinson.
Hey there, everyone. Tim Robinson, Astro Live Channel. Hey, nice to see you. So yeah, Shoemaker-Levy 9 was most likely had some kind of close encounter with Jupiter and broke up, right? We noticed this after the breakup occurred, right? So we don't exactly know what happened, prior to that, but it looks like there was some kind of a breakup, right, into like 21 pieces, right? And we discovered this thing, which was very, very odd, right? And then we noticed that its orbit took it such that it was going to slam into Jupiter, right? So, yeah, I don't remember the exact story, but I'm gonna want to say that Shoemaker-Levy 9 probably was some kind of a periodic comet that just was sort of in the wrong place at the wrong time and ran into Jupiter, which was a spectacular event. So yeah, I don't think that I don't want to say that comet was in any way sort of associated with the Trojans. Don't think so. Yep, don't think so. All right. So here's HST, looking at it. Keck, which is a...
I'm also am very concentrated about that Lucy probe and what the Lucy probe is going to do.
Yeah. Did you see that? I saw that too. They want to send a probe to this binary system. They want to launch it in 2021, and it will get to PM here, I guess in 2033. So wow, that seems like a long... I mean, that's...
Alan Stern, Astrolog Channel is saying Alan Stern, the head of New Horizons mission, said the decision to demote to a dwarf planet was bollocks.
Oh yeah. Like I said, I don't know. I don't quite understand why everybody is so upset about it. I don't see it as a demotion at all. It's just a designation, and I think Pluto's awesome, and I don't really care what you call it, because I call it awesome. So yeah.
You forgot about me, Astro Live Channel.
and like I said, I think our definition of planet is probably going to constantly be changing. So, if we think what we have right now isn't right, then there are ways to change it. And let's just go ahead and do that. That's the easiest thing. So yeah, and like I said, I don't really care what it's called. I don't see it as a demotion at all. I mean, it probably certainly doesn't care. So why should I? Yeah. Anyway, so here are the events. So yeah, they made these observations just to sort of establish a baseline, right? What are the brightnesses and colors of these objects when we can see them separately, right? Which I guess they can, you know, with the HST. It actually, you know, it might be really kind of interesting to see their data, right? So 2017, I wonder if their data is available for public accessibility, because we have enough information here to be able to find that data. Ooh, let's do it. Let's see. I don't know. I guess let's do it like this. Let's search with the names of the asteroids, which I'm not gonna say. Let's just do one of them. I'll bet you it'll find it. Okay, so there's that. Ooh, let's not resolve. Let's just see if it can come up with it all by itself. Ooh, I don't know. We'll try it with it off. Usually with planets, you don't have to, you know, name things. You don't have to have a resolver, but maybe we might. Let's see what this does. Ooh, it found some. Oh, look at that. And it's the right time, too. 1247. Okay, yeah, so here's some other ones that were actually more recently done. But let's look at the paper. We gotta, you know, let's look at the data that they actually grabbed with the paper. But it looks like they are looking at, they looked at it again, right? Because here's, wow, they looked at this a lot. So 520, 529, 68, 613, and 614, right? So that's, here's 520, here's 529, 529, yep. 608 at 0030, 608 at 030. Later, Tim. Thanks for coming in. Hope all is well with you. Say hi to Sue for us.
Yep. Good night, Tim. Good night, Sue.
613 at about 1230. Yeah, 1221. Yes, so these are it. Which ones? I don't think it really matters which one we look at. These are all like 60-second exposures. Looks like they actually took some images at different wavelengths too. You see in the paper, they were just talking about. Oh, okay, yep, they actually did. So most of their stuff, they use the 555, but they say a few frames were acquired with the 438 and 814. So that's nanometers, right? So all three of these are in the visible band. 438 is getting maybe a little into the violet, and 814 is definitely pushing the edge of the red. 555 is nice, right in the middle of the green.
Good night, Amethyst Crystal Photography.
Yeah, thanks for coming in. I will definitely check out. In fact, let me do it. I'm going to do it right here in front of everyone. I'm going to open this link. Go to your page. Amethyst Crystal Photography. Cool. So you've got several videos. Very cool. All right. Well, look, I'm definitely going to subscribe and hit that bell. Cool. Thanks. Thanks for coming in. All right. So let's see which one of these should we look at. It doesn't particularly matter. They were all 60-second exposures, I think. Yeah, 60-second exposures, 14928. Wow, look at all those observations they did. They got a lot of time on the HST. That's pretty cool. Lots of minutes there. Well, let's just look at the first one. First one here on well, I guess actually the last one on June 14th. Let's take a look at that one. It's right here. I don't even know if it's available yet. Oh, it's not available yet. Dang it. Well, let's see if these earlier ones are. Yeah, I was afraid of that. Dang it. Let's see, 555. Let's do this one. Oh, no, it's not available yet. Ah, that's a bummer. So, okay. Well, yeah. Well, let's look and see what they were doing, right? So we proposed to observe Trojan binary asteroid 6:17 p.m., one of the targets of the Lucy mission. Lucy was selected as the next discovery mission on January 4th, 2017, for launch in October 2021. Observations this year are needed to establish the mutual orbit of the binary, which is of critical importance for mission planning. The mutual orbit phase is essentially undetermined from the accumulation of orbit period uncertainty since last measured in 2010. Orbital phase is needed in order to be able to predict the timing of mutual events that will begin late in 2017. These mutual events are essential, blah, 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 blah. So, all right. Well, that's too bad. We can't see any of their data. There's some newer stuff that I guess probably is going to be even more not available. Yeah, bummer. Yeah. So, I mean, this is understandable, right? The people who want this data should definitely have first dibs. They should be able to work it, the way they want before anybody else gets their grubby hands on it, right? So I think that is extremely fair. They have worked for it. I'm sitting here, just grabbing things, right? Just being extremely rude and just grabbing things. So the fact that there's a little bit of time, right? I think PIs have, I don't know. It seems to vary a little bit, but I mean, even if they hold on to the data for a couple years, I have no problem with that. They worked hard, to get that data, and so they should definitely have first dibs. But the people who pay for it should also at least at some point gain access to it. And it is, but at this point it's not. So, oh well. Anyway, so here's what they currently think in terms of various orbital and other parameters. A pretty circular orbit, I guess. I think that's how I'm seeing. These objects are sort of moving around one another. They're moving around a common center. Yeah, I'm not quite sure if I totally understand.
So what are the, I've asked this question before, the asteroid belt and or just asteroids in general, where do they come from?
That's a good question. I don't think that there are any solid solid answers on that yet.
Let's say goodnight to Astro Live channel.
Take care, Astro Live channel. Nice to see you coming in. Nice to see you here. Awesome. So, yeah, astronomers can, at least modern day astronomers only seem to think in terms of accretion or collision. So there don't seem to be any other options available, where you know don't know. The bottom line is nobody knows, right? I think the current thinking is that the asteroid belt is either the somehow some kind of remnant of accretion from when the solar system was forming, or it's the result of some kind of collision between two or more bodies that created this huge debris field, right? Which is what the asteroid belt is. It's a debris field. But yeah, I don't think anybody knows for absolute certainty.
Wasn't there a question on the so-called I guess on the mass, on the amount of material that there is in the asteroid belt compared to what, like, say, a planet like Jupiter would be?
I gotcha. Yeah, I
There
don't.
just isn't enough rocks there to make a giant planet.
Interesting. Yeah. So I mean, at least from what we think we know about how much stuff there actually is, which could be right, could be wrong. Uh, that's another question too, right? Are you accounting for everything, even in your models, right? Don't know, but yeah, that's kind of interesting that what you're saying is that there doesn't seem to be enough material or mass, I guess, um, to account for like a planet-sized thing.
Yeah.
Yeah, interesting. Yeah, I don't have an explanation. You know, like I say, I think if anybody's really sure about any kind of explanation, that's a red flag to me. So I'll always lean on sort of the skeptical side, and give you sort of not really the answer that you probably want to hear. But yeah, bottom line is that nobody really knows. Um, uh, we up until recently, right? We've only had sort of one data point to work with, and and a lot of guessing, right? But now, we're moving into an era where we can observe other planetary systems and see what's going on there. Do they have asteroid belts, and what's the nature of those? So yeah, I think having one data point, and a theory of how everything was formed that is seems to match our observations pretty well. But how good are our observations? What's the uncertainty um, in what we think is going on? And I would say that the uncertainty is pretty high, right? So we might have a story, but if that's the actual story, probably not. Probably not. So yeah, don't have an answer at all. I think that it is pretty amazing, though. There are most likely, hundreds of millions of these objects or billions of these objects out there, and they're from what we can tell so far, right? They're just big rocks, right? As excited as everybody is about going and exploring these objects. They are just it's it's just dirt, right? It's just dirt and rocks, and so. But yeah, I mean, it's a new place, and those objects are in a completely different environment than the dirt and rocks down here on Earth, right? So yeah, they're definitely interesting. Anyway, so these two guys are going to be going through these mutual events, as they're called, when one object will actually pass in front of the second object. So here are some of them, and see. Let's see. So P is the larger body and M is the smaller one, with the arrow indicating its motion relative to P over 6 hours. Okay. The hatched region is the shadow of the foreground object. Oh, okay. Well, wow. So yeah, these can be complicated. Now, I guess the thing that is a little confusing is that, all these have happened. These haven't yet, but they're coming up really, really soon. So wow, that's kind of interesting. But let's see. So the bottom rows, so the top rows show example of inferior events where M passes in front of P, and the bottom one is just the opposite. Dark time near opposition. Okay, so they're saying that on April 3rd and April 5th of this year, we're going to have a couple more of these guys, and it doesn't look like there are going to be, at least I'm not seeing anything more. Let's see, we use our new orbit to predict timing of mutual events observable from Earth during the coming mutual event season that runs from fall 2017 through summer 2019. So, okay, so these might be the last two opportunities. Although they talk about summer, so I don't know. Yeah, I don't see anything else here. Dang it. So they talk about through the summer of 2019, but then when you look at the charts, it only goes to the spring of 2019. So I don't know what's up with that. But so yeah, kind of interesting to perhaps observe the light curves of these guys and see what's going on. So yeah, that's sort of where I was kind of interested in seeing. Let's go over to the Horizons website, and what I want to do is I want to see if I can get a predicted visual magnitude, because I think in the paper it was saying that these objects are like 49 kilometers in radius. Okay, so I guess they really don't even know how big they are. Let's see. System mass. Yeah, they don't really give a not that I can tell, no indication of size, although they're making these circles 49 kilometers in size and 45 kilometers in size. So for some reason they think that they're at least that big. So, all right. Well, let's see if we can find this guy. What's its number again? 600 and something. Where is it? Come on. You're somewhere. I know you are. I saw it here before. Introduction. There it is, 617. So I don't know how to search for this. Let's just do 617. 617. Small bodies only. Yeah, there we go. So we'll just keep the observer location geocentric, which is the center of the Earth. If you want an exact geometry, you would need to enter your latitude and longitude and altitude here. But I'm just interested in how bright it is, and that really doesn't matter in terms of where I am on the planet. So let's just look and see what it is on those dates. So where was the first one? 4/3/2019. They don't give a time, so we'll just go the whole day. 4/3, is that what it said? 04, 03, and 0404. 1 minute intervals. So we'll get 1,440 data points there. And I think server, let's just do plain text. And oh, I forgot to save that. That was kind of dumb. 403 404 1 minute. Specified times. There we go. Plain text, table settings. Let's see. Let's get into it here. Let's make sure that we're visual magnitude. Visual magnitude. That's what we want. Okay. Everything else doesn't particularly matter. We'd like to know where it is in the sky. That's about it. So, okay, use settings below. Let's do this. So apparent magnitude 15.78. Whew. Okay. Well, that's out of my range. Well. Yeah, that is definitely out of my range. It's in a nice part of the sky, though. It's in Virgo, right? Maybe even just east of Virgo, but somewhere in the Virgo area, at least. So that's pretty cool. If you're observing this, you can grab some galaxies at the same time. There'll be plenty. So it looks like it's like, if I'm reading this right, I think this is 4.9 astronomical units from the observer. We can confirm that. Range, delta, range rate, target center with respect to observer. Yeah. Astronomical units.
Yeah.
So yeah, 5 astronomical units away. That's a nice healthy journey. But yeah, it looks like it's pretty consistently magnitude 15.78, which that puts it way out of my league. I can actually
from the sun, right?
No, this is distance from the observer, I believe.
Okay.
Yeah, let's confirm that. Can we confirm that? Of the target center with respect to the observer.
Okay.
So yeah, that's from Earth.
Okay.
Yeah, at least that's how I would interpret that. Cool.
So 5 times
I
90.
really like the way how you do that. There's a telnet service for that Horizons thing.
Mhm.
Oh yeah. Oh yeah. 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 It's great. It's great. Yeah. It proves to be extremely useful sometimes, for sure. But yeah. So 4.9 times the average distance between the Earth and the Sun is about what 250 million kilometers away. So that's a little ways out. Um, yeah. Again, don't you know? I think astronomers like to throw out big numbers, to sort of impress people and stuff. I don't like to do that because it's sort of a relative thing, right? That I guess seems like a big number, but it really isn't. That's really really small. Um, I mean, you think about it, right? Step back a little bit, and it's like, wow, that is really really far, right? But yeah, it's just a matter of perspective. But yeah, it's pretty far, but relative, to other things, yeah, can barely see it. It's so close. But it is definitely very very faint. So with my scope, an 8-inch scope, can definitely probably be able to see something, right? But it's going to be super, super, super faint. So in order to really get anything on this, you would need, at least a 12-inch scope, or 14 or 16, um, to really start picking it out. So, and this is, I think, what they were saying in the paper, rather pretty clear or pretty close to um, opposition, right? Which means it's actually the closest it's going to get to Earth this time around. So yeah, these are about as good as you can get. So yeah, too faint for me to see. So oh well, that's a bummer. But yeah, this is pretty neat, though. How at sometimes they could even observe the shadows passing in front of these things. So yeah, pretty amazing, pretty amazing. Won't be able to see it from here, but hopefully those observations will be made, and we'll be able to just add that additional data to our knowledge base about these things. And I guess this is the first Trojan binary ever known. So that's kind of interesting. I'd want to check up on that a little bit and see see what's going on there. That just seems sort of unlikely, that there would just be one out of thousands and thousands and thousands of them. In fact, if you go to the Minor Planet Center, minorplanetcenter.net, International Astronomical Union, Minor Planet Center, you can see that so far there have been 789,000 asteroids, so-called minor planets, discovered. And this year we're just passing up our 1,000th one, just this year. So that's pretty extraordinary. Anyway, but yeah, we can actually go into here, and I think they have a list of the Trojans. See, and there's a bunch of other asteroid types as well. There's the Aitons, the Apollos, the Armors, the Centaurs, Trans-Neptunian. I don't know. I don't know which ones are the Trojans. Don't know. Let's. Google can be our friend again. Trojan asteroids. A part of a larger group? I don't know. Jupiter Trojans, co-orbital with Jupiter. Let's see if we can. Yeah, because I'm not seeing any. Oh, these are the unusual minor planets. Wow. Okay, here we go. Trojan minor planets. There we go. Just wasn't stubborn enough. So of course there are different kinds of Trojans depending on what planet sun Lagrange points you're considering. But it says up here that there are 7,039 Jupiter Trojans. So we can actually look at those. There they all are. Nope, don't want to translate. So here's just all the orbital parameters that are needed to observe these guys when we want. And I don't know a lot of these symbols. Eccentricity is this one, so that's how round or elliptical the asteroid's orbit is. I think A is the semi-major axis, which is a fairly ballpark idea about how far away this object is on average from the sun in astronomical units. So yeah, pretty far, 5.2 astronomical units. Here's the inclination of the orbit. So probably relative to the Earth-Sun plane, the ecliptic. So as you can see, it'd actually be kind of interesting to do a survey of the inclinations, plot all these inclinations and see what the distribution is. That'd be an interesting thing. It'd be interesting to do that for all of these. These are the absolute magnitudes, which in planetary magnitude reference, that's the visual magnitude of the object if it's at 1 astronomical unit away. So as you can see, a lot of these are pretty faint, right? And depending on how far away they are, they can be much more faint, right? These numbers are all related to how bright they seem to be if they were placed at 1 astronomical unit away. Well, there are no Trojan asteroids that are ever going to be 1 astronomical unit away. They're always more than that. So they're going to appear much fainter than all of these numbers, right? But there's a couple of them, just a couple. You can sort of see their names here sort of give away their birthday, or at least their birth year. 1973. Not quite sure why that's a different number there. Hard to tell. Anyway, yep, just mountains and mountains and mountains of data here. 7,000. How many were there? 7,039 Jupiter Trojans, and only one of them is a binary. Oh, come on, got to be more than that. All right, well, cool. I just thought, you know, that was kind of an interesting thing, and I was curious if I'd be able to see this in my setup, and yeah, no, it doesn't look like it's going to happen.
So James still again, too lower magnitude in my light polluted skies. I guess about 8. Any more than that is just too dim, unfortunately.
Yeah. No, you're this. Yeah, I mean, at 15.8, you're looking at some faint stuff. So yeah. All right. Well, cool. I think that I'm noticing what time it is, and I think I just want to get out of here for today. We didn't actually get very far into any of the new papers or anything, but that's okay. You know, we come around to all these things. There's always so much that it's just absolutely impossible to even try to cover just the smallest amount of stuff, because the universe is just amazing, right? There's just there's just all kinds of things. You know, there's old stuff to learn about, right? There is sort of the current stuff that you have to wrap your head around, right? And then there's all this new stuff, right? And it's just, yeah, it just goes on and on and on and on and on. And what I like to do here each and every day is just share the passion, right? Just you know, take a little bit out and just be, you know, completely blown away by it. That's exactly what I am.
Quick thought before you go.
Sure.
About the Goldilocks zone. If there was a planet where the asteroid belt is, would that change where we are?
Yeah, that's a good question too. It comes down to center of mass, right? And so if the current asteroid belt has sort of distributed itself in such a way that when you all of a sudden you just sort of, you know, connect all these things together, if the mutual attraction is the same, then the orbits aren't going to change. That's extremely unlikely, though, I would say. As far as I know, there are no unknown large asteroids that are sort of, you know, not being seen, not being detected. It's, you know, but it's entirely possible. You know, if these things are like really dark, right, but really big, well, one, you're not going to see them very well because they're so dark, right? So big things can potentially slip through, but yeah, hard to know for sure. That's always going to be my last answer. Is like, I don't know. But it's nice to think about, and
leaves a cliffhanger for next time.
I guess, yeah. But you know, these things are always nice to think about and postulate about, and you know, see what others you know, who know much more about all these things, you know, than I do. You know, see what they have to say about it. You know, the ones who are actually thinking hard about these these things. And so yeah, you know, there's I don't think we'll ever have the answers. I sure hope not. So it'd be a boring place, I think, if that ever happened. So, all right, everybody. Well, I think I'm going to get out of here for now. I'm just going to check the chat one more time, make sure that there isn't anything too outrageous or outstanding. Nope, I think we're good. I think we're good. All right, so I'm going to get out of here for now. So peace, cheers, and all that, everybody. I will see you in about 22 hours and 35 minutes. I think that's how that's going to go. So yeah, I'll see y'all next time. Next time for me will be 2 hours UTC tomorrow, for sure. Let's do some more astronomy. It just goes on and on and on. All right, buddy. Take care. I'll see you later. Bye.
Live long